In this part of the lesson, we walk through the code step by step using the F8 key. This lets us see exactly how VBA executes each line and how variables appear in the locals window as they receive their values. When we press F8 for the first time, VBA only highlights the first line. Pressing it again actually executes the instruction and immediately displays the assigned value in locals. When VBA reaches the line declaring a byte, we instantly see a value restricted to the 0 to 255 range. Byte is useful only for very small numbers, such as compact category identifiers or flags in financial models. A moment later, when the integer assignment executes, locals shows a wider but still limited range. Here we can observe an important behavior. Assigning a decimal value results in the fractional part being removed because integer cannot store decimals. In finance, integer is suitable for values that are naturally whole numbers, such as the number of periods, installments, or quarters. Next comes long, the most frequently used integer type in financial VBA work. Long handles numbers up to billions, making it ideal for transaction IDs, indexing large datasets and rows, or iterating through extensive financial tables. Watching its value appear in locals clearly illustrates its practical capacity. Then we reach long, available in 64-bit VBA. Its enormous range makes it suitable for exceptionally large identifiers or heavy simulations where standard integer sizes are not enough. Together, these four integer types demonstrate how VBA scales from tiny whole number values to massive 64-bit ranges. In financial programming, selecting the proper type ensures accuracy, prevents overflow, and keeps calculations efficient. Moving on with F8, we reach single and double. Single stores decimals with limited precision, while double maintains higher precision and is commonly used in analytical financial computations. Currency displays values with 4 decimal places and is ideal for financial amounts, balances, or interest calculations because it avoids floating point rounding errors. Decimal, inside a variant, maintains very high precision and is helpful for tax calculations or exact financial allocations. As we continue through the code, we encounter date, Boolean, and string, which display their assigned values the moment they execute. Date taking the current system date, Boolean showing true or false, and string storing text. Finally, when the loop reaches the part writing all values into the worksheet, each range.value instruction fills the sheet cell by cell. Stepping through these lines with F8 reveals how VBA transfers data from memory into Excel in real time. By the end of the procedure, we have seen the entire flow: variables declared, assigned, displayed, and finally written to the sheet. Walking through code with F8 provides a clear understanding of how VBA processes each variable and how data moves from code to worksheet. There is also a crucial point for financial applications. Choosing the correct data types matters for 2 main reasons. First, it guarantees the required precision. Financial calculations often cannot tolerate rounding errors. Second, higher precision increases computational cost. Using overly precise types on large datasets can slow down processing significantly. Balancing precision and performance is essential in building efficient financial models. And finally, remember that variables, as the name suggests, are meant to change. They can be reassigned or overwritten at any time during execution. Constants, declared with const, cannot be changed once set. Their value remains fixed throughout the program. Use variables for values that evolve during calculations, and constants for values that must stay stable.